Good morning. This is Schweitzer, and here we're going to give just a couple brief introductions into some answers of our English metric worksheet conversions. Now, again, this particular exercise is twofold. One is, can you set up equivalencies for factor label? That is probably the number one goal. All right. So factor label. The next aspect of this is that we often use, the metric system a lot. We don't use a lot of the little intricacies of it, but there's some things that we use a lot, like millimeters, milligrams, kilograms. And we want to be more familiar with the metric system and how it just in generally its conversions. There is a video on that, and you should have already watched that video before you do this. Either way, let's take a moment and just kind of see a couple of answers here on how this works out. Okay, so first things first, the first problem, I'm just going to point out that here as I'm going from meters to centimeters. This is a metric unit to a metric unit. Okay, so I can, with knowledge of the equivalencies of the metric system, can jump right from here to here. Okay, there is 100 centimeters in 1 meter. If you don't know why that is, watch the metric video. All right, so here's how I set it up. In one step, 125 meters. I'm going to get rid of meters and go to centimeters. 100 centimeters equals equivalent to 1 meter. And therefore, 12,500 centimeters is equivalent to 125 meters. Okay. Let's do it. So this here, I have set up my brain already. I have an equivalency. I'm going to go from meters directly to centimeters. That is my plan. The rest of this is just manual labor. If you understand how to do the factor label setup equivalencies, then you could hire a 5th grader to do this for you. You'd give them the instructions, the pathway and the equivalencies, and they can set it up. It's just a matter of process at that point. So here, millimeters to kilometers. Now again, in the metric system, all my conversions are even, so I can jump from one unit to another unit very easily. In this case, I'm going to jump from millimeters directly to kilometers. All right, so I'm going to go millimeters directly to kilometers. And if you're just getting familiar with some of the metric system, 1 million millis is 1 kilometer. All right, so 0.26 millimeters dot line, get rid of millimeters and go to kilometers. 1 big kilometer is equivalent to 1 million small millimeters. And simply divide out. So you take, because it's on the bottom we divide, so on the top we multiply, on the bottom we divide. So 1 doesn't do anything. I could take this thing and I'll go 0.26 times 1 is just going to be 0.26. Divided by 1 million is, all right, here's what my calculator spit out, 2.6 e to the negative 7th. All right, that means it's 2.6 times 10 to the negative 7th. That's equivalent to, all right, move this thing over 7 spots. And that is where you would be. So 1, 2, 3, 4, 5, 6, 7. And that's where my decimal place is. So it's a small number either way. So that's a quick little review into this. Now, very important, if I want to type this number into my calculator, again, your calculator is set up to do scientific notation very easily. You just type in 2.6, and then you'd use, on your calculator, there's a button, you'll find it, and typically it says E. Alright, and mine's the second function of the comma, but you look at it, and then it's going to give you 2.6 E, and you just type in -7, and that's how you get that particular value in there. Either way. All right, so I've made a couple of these involving metric system. Now, the English system is not as nice, you might say. So let's do number 5. Now again, the first set up for this thing is just my plan. All right, what equivalents do I know? Again, on the English video, they give you some equivalencies. And you can go to Google and type in cups to gallons if you'd like. Okay, I don't necessarily know how many cups are in a gallon. So I'm going to go from cups. I'm going to reach in my memory bank of some of these equivalencies. Cups, I'm going to go to pints. I happen to know that there is 2 cups in 1 pint. Okay, then I'm going to go from pints to gallons. I know that there are 8 pints in 1 gallon. Now, if you don't know these equivalencies, you got to watch the video and get aware of them or Google them and get it in internet search. Once this is done, I have my pathway with my equivalencies. Again, it's just manual labor. 2,500 or 2,500 cups. Dot line. Get rid of cups and go to pints. Get rid of pints and go to gallons. 2 pints equivalent to 1 cup. In this case, 8 pints equivalent to 1 gallon, and our answer can be easily calculated. All right, on the bottom here, there's a couple more examples. All right, let's see if we can scroll down here. Here we go. It's asking for some conversions. All right, now scroll down. There we go. All right, so in this case, there are some standard conversions that you could Google or whatever. It's giving you some links between the English and metric systems here. All right, so just so you know, it's 2.2 pounds is to 1 kilogram, and there's 2.54 inches to 1 centimeter, and there's 3.78 liters into 1 gallon. All right, so I'm just going to do 1 or 2 of these. This is an English unit. This is a metric unit. So pathway, I'm going to use this bridge, this equivalency to get from a length of English to length of metric. So I'm going to go from feet to inches. I think most will know that's 12 to 1. Now I'm in inches. I'm going to jump from inches into centimeters. That's my bridge. In centimeters, I can jump right to meters. There you go. This is going to be 12 dot line. The rest of it's just manual labor. Feet to inches. Dot line. Get rid of inches. Go to centimeters. Dot line. Get rid of centimeters. Go to meters. Equals. This is going to be 12 to 1. This is, as given right here, 2.54. Now, why is it on top? Because 2.54 centimeters equals 1 inch. And then 100 centimeters equals 1 meter. And therefore, my answer is in meters. There is one little trick question sort of down here. I have a volume here and I have a mass here. Therefore, we would need a relationship between volume and mass, or mass and volume. Okay, well, everything, this is called density. So it's not that this problem is impossible to do. We just don't have enough information. And we would require a density. Some kids will automatically use a density of 1. And that is for water 1 gram per 1 milliliter. But in this case, if it was water and we gave the density, we could use that. But we don't know for sure. All right, so just a couple examples that you can utilize to get yourself on a good track for this section.